Hello, my name's Tanam Shaw and I'm from UNSW. Today I'm working through some of the Math 101 calculus questions from section 2.6 on implicit differentiation initially. So question 1 and 2 are after asking us to implicitly differentiate, first to find dy dx and then to find dx dy. So I've chosen parts B and D here. So what we would like to do is, with this expression here, differentiate both sides with respect to x. So differentiate 2y plus y squared with respect to x, and that must equal the derivative of x cubed minus 4x with respect to x. Now, we can just differentiate 2y and then add the derivative with respect to x of y squared here. So when it's a plus, we can separate the derivatives there. Same when it's a minus. So this is the derivative of x cubed minus the derivative of 4x. Okay, so plus and minus, we can separate the derivatives out like this. Now, if I want to differentiate 2y with respect to x, well, that's just 2 times the derivative of y with respect to x. So 2 times dy dx here. Plus, if I want to differentiate y squared with respect to x, well, y is really a function of x. It's just implicitly defined. And so I have to use the chain rule. Y squared differentiates to 2y, but in addition, I need to multiply by dy dx. That's what the chain rule says there. Just x cubed differentiated with respect to x, that's just 3x squared, and 4x differentiated with respect to x is just 4 there. Okay, now our aim is to find dy dx, so I'd better factorize it out here. Dy dx outside of 2 plus 2y is equal to 3x squared minus 4, and so dy dx is just equal to 3x squared minus 4 divided by 2 plus 2y there. So there's dy dx. Now if I wanted to do question 2, what I would do is I'd differentiate both sides with respect to y. So just to say that we're going to do 2b now. So same expression, 2y plus y squared equals x cubed minus 4x. What we're going to do is differentiate with respect to y. So d dy of this must equal d dy of this. Now 2y differentiated with respect to y is just 2, and y squared differentiates to 2y when you're differentiating with respect to y. However, x cubed, we would need to use a chain rule. X cubed differentiates to 3x squared, but in addition I would need to multiply by, not dy dx, in addition I would need to multiply by dx dy. And differentiating 4x with respect to y, also minus 4, differentiating x with respect to y is just dx dy there. Okay, so I can factorize dx dy out on the right hand side here. Dx dy is 3x outside of 3x squared minus 4. And so then I can make dx dy the subject, and that will be 2 plus 2y divided by 3x squared minus 4. So we can see, actually, it's just the reciprocal of dy dx, which is what we would expect there. Okay, but you can start from scratch and differentiate both sides with respect to y. So we just can't forget the chain rule in those sorts of questions. Now for part D is slightly more complicated because we have some products here, x times y and x squared times y squared. So let's just do question 1, which is implicitly differentiating to find dy dx. So we would differentiate both sides with respect to x. So that would be differentiating xy with respect to x plus differentiating x squared y squared with respect to x. If that's just a plus, we can differentiate separately and we can add. If it's a times, we can't do that. We need to use a product rule. So let's just finishing this off. We're differentiating here 4 with respect to x. Okay, so we would need to use a product rule here for differentiating x, y. So remember our product rule is f dash g plus f g dash. So here, f dash g is 1 times y, because we're differentiating with respect to x, so x differentiates to 1. Keep the second, f dash g, plus f g dash is x times, well, y differentiated with respect to x is dy dx. So I might just keep that in brackets for the first bit. So here we have f dash g plus f g dash. Okay, we had to do a product rule for that first one there. For the second one, we will have to do a product rule as well. Here f is going to be x squared and g is going to be y squared. So differentiating with respect to x, f dash is just 2x, g is y squared, so f dash g plus f is x squared, g dash, now if g is y squared, differentiating with respect to y, g dash is going to be 2y dy dx. So all of that is g dash. 4 differentiates to 0 with respect to x. So here we had an f dash g plus an f g dash. All of this here, that was a pretty terrible bracket, all of these there, all of that there is a g dash there. Okay, now we want to make dy dx the subject. So let's do that. I might just rewrite this as y plus 2xy squared. So put these ones next to each other, plus, and I might put those next to each other, x dy dx plus x squared 2y, which I'll write as 2x squared y dy dx. I'm trying to make dy dx the subject, so I might factorize the dy dx out here. And I'm left with x plus 2x squared y. And I'll take this over to the other side. So that will be minus y minus 2x y squared there. So dy dx is just going to equal minus y minus 2xy squared divided by x plus 2x squared y. Now we can factorize the top and the bottom here. So if I factorize out a minus y, I'm left with 1 plus 2xy. And if I'm factorizing out an x on the denominator, I'm also left with 1 plus 2xy. So in fact, as long as these aren't 0, I can cancel them off. So in fact, this equals minus y on x. I might just write here, as long as 1 plus 2xy doesn't equal 0. If 1 plus 2xy does equal 0, something funny is going on with the gradient, and we'd need to explore that a little bit further. Now, question 2 didn't actually ask us to look at part D and write dx dy, but you could do it from scratch. You could find d dy of both sides, and we know that in the end, our answer, if we wanted dx dy, then our answer for dx dy would end up as x outside of 1 plus 2xy over minus y outside of 1 plus 2xy, which is x over minus y, as long as these aren't 0 here. Okay, so you could do that, differentiate both sides with respect to y, and see if you get this answer for dx dy.